Another reaction that you'll see here, besides, so we already talked about phase 1 ester hydrolysis, we talked about phase 2 N-acetylation. Now we're going to talk about phase 1 N-dealkylation. So phase 1 N-dealkylation is going to occur whenever you have a carbon-nitrogen bond, but you want to make sure the carbon has at least one hydrogen on it. Otherwise, oxidation cannot occur. And we know that N-dealkylation is under our broader umbrella of oxidation reactions. So N-dealkylation is number 3 here. It's part of oxidation. Remember, oxidation, you must have at least one hydrogen on that carbon of interest before it can undergo oxidation. So if we pay attention closely, this carbon in this carbon-nitrogen bond right here has at least one hydrogen, so that's okay. This carbon in this carbon-nitrogen bond has at least one hydrogen, so that's okay, and same with this one. So N-dealkylation can actually occur here, where I cleave that bond, I can cleave this bond, or I can cleave this bond. And with N-dealkylation, I want you to keep this in mind. It's kind of like when we talked about O-dealkylation in our naphthalene problem. So whenever you see a nitrogen attached to a carbon, assuming that this carbon has at least one hydrogen, you cleave that bond, so what will happen? What will happen is the carbon side will get an OH. Okay, so the carbon side will get an OH. So I'm just going to write that like this. So the carbon side will get an OH, and the nitrogen side will get a hydrogen. So we're adding water overall. So keep this in mind when I draw out the structure. The carbon side is going to get the OH, and the nitrogen side is going to get the hydrogen. So what I'm going to do is I'm going to focus on just drawing out the product if I was to cleave this bond right here. Okay, so that's the bond we're focusing on right now. So I know a lot is happening here, so I'm going to redraw that. I'm cleaving this bond right here. So when I cleave that bond, I'm going to redraw my structure. Okay, so now we're going to pretend we're going all the way down here, and this is going to be a phase 1 reaction, and it's going to be N-dealkylation. That's the name of this reaction. Okay, so phase 1 reaction, N-dealkylation. So you can pause the video now and try to do it on your own, and then I'll show you how to draw it out. So for this, I'm going to draw out my structure here. And so a lot of the structure is actually going to stay exactly the same. So what I'm going to end up doing, just for abbreviation, I'm just going to put an R group here, an oxygen here, and then I'm just going to continue drawing that part of the molecule. And then I'm getting to that carbon where the cleavage happened. And so what happens to the carbon side? The carbon side should end up having the OH, right? So the carbon side is going to have the OH. So I had 1 carbon, 2 carbon, 3 carbons. So the bond that we're breaking is this one. So that means that that carbon, this carbon right here, okay, this carbon right here in blue is this carbon right here. And so that carbon is going to get my OH. Carbon side gets the OH. So that blue carbon is the carbon that got the OH. And then the nitrogen side is going to get a hydrogen. And so now I'm going to redraw the nitrogen side of the bond. So you're literally cutting it in half. Okay, and so when I do that, I have this nitrogen. It's attached to these alkyl chains that are pretty large alkyl chains. Okay, and then that nitrogen is attached to a hydrogen. Okay, so again, I always like to think of this top part here. This is what I draw out, and just so I can visualize it. The nitrogen will get the hydrogen, the carbon side will get the OH. It's just like the O-dealkylation. So in this case, I see that my nitrogen got the hydrogen. This nitrogen got the hydrogen, just like we predicted, that the nitrogen would get the hydrogen and the carbon would get the OH. So that's your product. So what have we formed? We have formed an amine, right? And so I see that I have formed that amine with the NH and the alkyl groups, and I've also formed that alcohol. But remember our oxidation video that we went over, this is most likely going to go through the full oxidation series. So right now it's at an alcohol, but it will probably go on to the aldehyde or ketone, depending on what you're looking at. And then it will go all the way to our carboxylic acid. So this alcohol is going to go all the way to that carboxylic acid. So I can redraw that part of the molecule again. And then now, instead of having that OH, I'm going to have the COOH instead. So that's the COOH, right? And so that carbon is going to end up having the COOH. So if we look closely, we had one carbon here, one carbon, two carbon, three carbon, one carbon, two carbon, three carbon. The third carbon is what had the alcohol, so one carbon, two carbon, three carbon. So I actually just caught a mistake by doing that. I should only have three carbons, right? I can't just add a carbon. So I have carbon 1, carbon 2, carbon 3. Carbon 1, carbon 2, carbon 3. Carbon 3 got my OH, right? Because remember, we said that the carbon side gets the OH and the nitrogen side gets the hydrogen when we cleave that bond. So the carbon got the OH, and so therefore when I write this out, I actually drew out an extra carbon. So what I should have done, is I should have gotten rid of that. So my third carbon is the carbon that ends up getting turning into the COOH. So that's carbon number 3, and that's the same blue carbon that we've been following all along. Okay, so how would you see this on an exam? On an exam, most likely you won't draw all of this out. Instead, on an exam, you'll be given this structure up here, which is structure A. Then you'll be given an arrow, and then either this structure will be given or this structure will be given. And you have to figure out what happened. And this is what we call kind of like our side product, because this is the side product of the cleavage. So if you see, let's kind of zoom out, if you see A going to B, you also see this side product, well, you'll just look at your molecule and say, okay, so by the way, this R group is just abbreviated. That's the R group. So I'm looking through the molecule and I'm saying, okay, well, I still have my carbonyl, I still have these alkyl groups, and I'm just tracing through and I see, oh, a cleavage happened right here. What is that? That's N-dealkylation. What is N-dealkylation? N-dealkylation is a phase 1 reaction. So it is a phase 1 CYP450 mediated metabolism reaction. So it's this reaction right here, N-dealkylation. That's what we just went over. So that's for butane. And then you could redraw the same thing if you were to cleave this bond or this bond, but remember, in order for N-dealkylation to occur, your carbon has to have at least one hydrogen on it. A lot of things that confuses students is if you see the OH, right, you're predicting, oh, well, the carbon side is going to get the OH. Why is it suddenly, instead of a CH2OH, why is it a COOH? And that's because it's going to undergo oxidation from alcohol to aldehyde or ketone to carboxylic acid. And don't make the mistake of adding carbons like I just did. Okay, so I want you to go ahead and think of any other reactions that you think might occur here. Specifically, you can use your lecture notes to see if you can draw out a reaction with omega oxidation or omega -1 oxidation. So you can look into what that means and see if you can figure out how to draw the metabolism reactions that are omega or omega -1 oxidation reactions. And those are actually part of that omega and omega -1 is part of a reaction we haven't talked about yet, which is aliphatic hydroxylation. So before the next video, see if you can figure out omega and omega -1 oxidation.